Good afternoon, ladies and gentlemen. Thank you very much for coming to my session. I am in iOS client development. My name is Masaki Fuke. In the past, I have been responsible for stickers, themes, management, as well as client-side implementation and the suggest functions implementation in the shops. Today, I would like to talk about the PIP picture-in-picture functions that you can use to watch the video while chatting. Now, we call it PIP because we're talking about iOS. Now, before we enter the major topic, let me just briefly go through the Line iOS development. Line, from the release in June 2011, it's been 6 years, and the source is 6 years old as well. Initially, it was MRC, and Week was not available. However, we started development then, and we're focusing mostly on Swift. Actually, Line was using Swift from the very beginning, since the days of Swift 1. And the new functions were using Swift, and the legacy functions were typically Objective-C maintained. However, Swift codes is about 30% of the total codes today. Now, development work is done in different parts of Asia. In Japan, we have bases in Tokyo and Fukuoka, as well as Korea, Taiwan, and Dalian. Aside from this major project in Line, there are different functions being developed in different projects. And so services that have high affinity with the main applications are using Git's submodule, and for other independent libraries, as well as external libraries, we're using CocoaPods. And more recently, we are using more Swift internally in developing libraries, and therefore we're introducing Cartage. And so it's actually using both CocoaPods and Swift as well, and Cartage. So let me explain why we decided to implement PIP. In the Line, in the chat room, it's actually quite important as a messenger application. It's a main function, and I'm sure that many of you use this and you're very familiar with this function. But going forward, I think there are things that we need to do because of the current situation. So with that in mind, we try to really focus on the better communications in the chat room, and we developed a task force, and that's chat room task force. And there are various projects underway which will be developed further. So we ask for your kind cooperation and expectation. And actually, we wanted to really enhance the media convenience using images as well as videos, and we had to address this issue that was related to the exchange of videos, and that issue had to do with picture-in-picture. So let me show you the video that shows the function of PIP, picture-in-picture. I'm sure there are many occasions where you want to send and receive videos such as from YouTube or others, and you take a look at the video, and then the other person on the other end doesn't know that you're watching the video, and then the chat will just progress without you, and you're left behind. And you might want to respond immediately. However, when you want to respond, you close the video, and then you have to restart again and play the video again. So it's sometimes a problem. And then when that happens, click the button on the top right. And then the size of the screen will get smaller, and then you can actually respond back to the chat. This PIP actually will keep showing in the main tab as well as in the current the layers inside, and you can actually look at the timeline while the video is being played. So to summarize, so PIP actually makes the size of the screen smaller so that you can continue chatting while watching the video. And of course, you can just scroll over the small screen to different parts of the screen, and you can bring it back to full screen size as well. And it now can be used with a video message and YouTube video. And this version was released in middle of last month, so you can try it. Now, here's a question. Why did Line decide to implement its own PIP? Well, in iOS, from iOS 9, PIP functions have been released, and this is available only in iPad. However, as I just showed you earlier in the video, iPhone being able to leverage this function is of high quality. However, there's no PIP method that can use official API in iPhone, so we decided to develop it from scratch. And like the iPad PIP, we cannot really show this video over different applications, so please do understand that limitation. Now, there were two barriers that we had to overcome in implementing PIP in line. Because of the lack of official API, what were the methods that we could use to implement this function? And also, audio session management, that becomes very important in video. Let me just talk about these two areas or challenges. So starting with the implementation. In developing the PIP function, the question was how to design it. And the first was to develop a view controller for each of the PIP functions. And subclass of UI view will be developed, and PIP will be the way it's shown. However, the lifetime of the view controller that you display will be different from the lifetime of the PIP. Therefore, you cannot really delegate it. And therefore, you typically might include the logic in the controller within the UI view, but you want to avoid that. So we made sure that for showing, view controller was to be used as a must. And then the second is to develop a container view controller and then show a smaller PIP view controller and realizing it. So we decided this policy of using or developing view controllers to show PIP. And we decided to develop this container view controller. And the benefit there is that you can use the same life cycle as a view controller that you're used to. And the third point is to make it easy to show the PIP. And so for ease of use, we try to actually display the PIP simply just like a present model. So let's talk about a view controller being developed for PIP. And we developed a new controller, or rather a new protocol. And this actually has the setup for describing different necessary information for PIP, such as the location of display as well as the minimum size. And Swift 3.2 actually can define class and protocol in conjunction, and so we can make the following descriptions. Now, the PIP size information itself cannot be set, and so the size of PIP, as you saw in the video message, sometimes the video might be in landscape or in portrait form, and Instagram and other services might use different kinds of sizes. And so these are the same video message PIPs. However, the PIP size will be determined by the contents. It will depend on the contents, and therefore, although the function might be the same, the size of display might not be the same. So what should we do about this? Actually, in the UI view controller, there is already a property that is used for setting the size, and that's called preferred content size. It says preferred, meaning that it doesn't need to be that size. It's not a must that you show it with that size, but the right to decide whether to use that value or not is on the side of the container view controller. And we decided to use this container, we decided to use this container view controller for the container for PIP this time. And when you change the child view controller preferred content size, and then that change is notified to the parent view controller, and the benefit is this using this preferred content size did change, you can actually receive the change notice that overrides it. So we developed the PIP layer view controller, and to show the PIP, we have this view controller, and add child view controller is used to show the PIP view controllers. And so how do we put this displayed on the line? And this is the chat screen. This is the PIP layer. In other words, we're trying to overlay the PIP layer view controller on this chat screen. And if we can do this, then PIP can be realized. Moreover, the PIP view, or rather PIP layer view controller, has to keep on displaying the image even if you change screens. And so how can we really overlay this PIP layer view controller? Now, I used the word PIP container many times, so why was I so persistent in using that term? Actually, there is yet another upper layer for overlaying the PIP layer, and that's the line root view controller. And actually, it's an orthodox design showing UI navigation controller that is shown in the UIT tab bar controller. That is the initial screen. And so line root view controller is the parent view controller. And the existing tab bar controller is to be the child view controller. So in the past, UI Windows root view controller was UI tab bar controller, but we changed the root view controller to line root view controller and decided to have this overlaid. There was a risky that was a risky change because it was already 6 years since we started this, and we never knew that some codes might have assumed the root view controllers being the tab bar controller, and however that worked well. So now we were able to show the picture or the video in the picture in the chat room and other screens continuously as well. So next we thought about how to display this simply. And if we are to show this hierarchy of the view controller, it looks like this. And in the chat room, against the PIP layer, you have to hand over the PIP view controller. However, from the chat room to the PIP layer, the distance is quite long. In other words, handing over a certain object to the PIP layer seems quite difficult to do. And therefore, the target view controller for action sender, which is the UI view controller API, was used. And this method was added to iOS 8. And the logic of transitioning of the screens is to be delegated to the parent view controller. And we use this logic in a similar manner. Methods such as show view controller and show detail view controller were added in iOS 8 as well. And so without touching directly the navigation controller, you were able to do push. And so that method is implemented. And as a behavior, it's like the view controller version of the responder chain, and the called view controller hierarchy is followed so that you propagate this using the method that can be used for the parent view controller. And if there is a view controller that you can call, then you give a response back. Luckily, we added this line root view controller. Therefore, the handover to the PIP layer was to be done now by line root view controller. And the UI view controller has this extension, and we added the show PIP method, and therefore PIP can be called anytime. And so chat room to view controller hierarchy, it actually goes up to line root view controller, and then the line root view controller goes through this handover step, and the PIP can be displayed at the end of the day. And so this is really what we have realized within line in terms of PIP function. And as I said earlier, there was a need to fundamentally change the structure to implement this. However, what we found out is that by having this our own custom class of the root view controller of UI window, we have higher levels of freedom for changing the screens, and we believe that there's a lot of potential going forward for the implemented line root view controller. So we would like to do more research on this.
Next is about audio session. In implementing PIP function, it took about 2.5 months in total. For the design of PIP, it took about 1/3 of that time. And the remainder of the time was spent in solving this audio session issue. Why did it take so much time? Firstly, let's review what audio session is. Audio session means that it sets the audio usage status on at the OS side. So the background music is stopped so that you can play in-app video audio. And in silent mode as well, you can have audio from the speakers. So you can do such settings. In LINE, audio session management used to be managed by each function at each timing of using audio session. And LINE has the important function of VoIP. VoIP also uses audio session. In this case, VoIP is at the top priority. VoIP, when VoIP is active, the other features cannot change audio session. So each function would first check if VoIP is calling. And now we need to respond to PIP. PIP's life is longer compared to other functions, so it overlaps with other features. So following VoIP, PIP should also be referred and checked by other functions, but actually this is not impossible. We cannot do that. Therefore, we need a middle layer to manage audio session status. Firstly, each function describes the audio session setting it wants to use, and we call this a state. And the middle layer would manage multiple states, and it would decide from the current state to the ultimate audio session state. What's important is that we don't change audio session directly. When each feature uses audio, the middle layer audio session would add the state. The state is prioritized and it chooses the top priority feature. The state can request setting to audio session. So the highest priority state would be the current audio session setting. If there is no setting in use, the state is checked once again, and the next highest priority would be set. So this is an easy and simple rule. We needed to implement this to all functions using audio, and this took so much time, and that is why we spent so much time to solve this issue. I was alone in working on this, but actually it was too much. Therefore, we decided to share this task amongst team members. The good thing about team development is that you can work together amongst the members. And state is summarized in enums in Swift, and object C is going to be used. Therefore, int is also carried over, and raw value int is used as the priority. And as it is defined later, it would be higher in priority. And another benefit using middle layer is that each feature can delete the codes pertaining to VoIP, and so that we can eliminate the dependency. And VoIP and PIP, which are functions that use audio for a long time, such functions can be added easily. And even if we have multiple features at the same time, we can understand the state more easily. For example, during live play, line music message may be played and voice message may be played while the sound stamp is sent, and it would randomly end. In such a state, we could not understand what was happening in the prior management, but now we can understand. However, at the same time, we face many issues. The first issue was the stake leak issue, leaking of the stake. It is difficult to manage this correctly. If we release the state and fail in the release, the state would be leaked. And in the new camera function, line which is being developed currently, it would change audio session. And so we need to think about how to deal with this issue of camera function. And also, in deactivation of audio session, there were some issues. So firstly, with staked leak issue, we manage the stake in array, but if we fail to delete it, the state would remain there forever, and that would cause severe issues in the implementation. Therefore, we use weak reference dictionary called NSMap table, and this is used for management. When we set the state at the beginning, we specify objects that ensure the lifetime of the state, so that when the object is no longer there, the state would also be deleted at the same time. And this minimizes the leak of state, and it is easier to manage. Next is about projects that may change the audio session directly. We set the rule not to touch or change the audio session directly. But if we apply this to other projects, it would be a major issue. But if there are functions changing audio session, the audio session management would be broken. Therefore, audio session management can be suspended temporarily as an option. So while you're using the function for that project, the management of that function is done by the feature itself. And then after that usage, the management would be returned. So this is how we solve this issue. And lastly, it's about the issue of deactivation. The sound of application can be centrally managed. So when the state is empty, audio session is deactivated so that background music can be played again. But an issue occurred when we did this. That is UI freeze phenomenon when sound fades out. When we do deactivate, the sound would fade out and background music would be played, but the OS would stop the application UI. Then, in the timeline, the inline video and video player switching would freeze, and user experience would deteriorate as a result. And while playing the video, when you change the audio session, even if you are set on mute, the audio would not be played. So how we solve this issue is that we gave up on deactivate. Instead, when the state parameter is empty, we use the ambient setting that allows the play of background music. However, with this, another issue occurred as a result. And these are the two issues that occurred. Firstly, after ending VoIP, the background music would not resume. And also, functions that should not stop background music would stop the background music. After ending VoIP, BGM would not resume. In such a case, we decided to add another option. When state is deleted and there is no other state active, then we would deactivate. That is the option added, and it is very simple. So this is applied to VoIP as well as voice message. Another issue of features stopping the BGM when it's not supposed to. The cause was ambient would move from playback mix with others option, and at that time it would stop the background music. So this would occur even though it is allowed to play the background music. So we found out that when we change the setting, if we momentarily deactivate, we can do the play without stopping the audio. Therefore, just before the setting, we would momentarily deactivate, and after the change in setting, we can activate right away. So this is an option, the tricky question that we added. So through such efforts, we were able to solve various issues related to the overall management of audio session. Ultimately, audio session state is the definition of case as well as audio session setting and bool value properties. The three bool value properties were added. Handle session myself. This is to abandon the session and deactivate. When there's no other state, it would deactivate. And won't activate when adapting. So before setting, you would momentarily deactivate, and after setting, you would activate once again. This is a summary. In order to realize PIP, we had to change the structure of line view controller. Moreover, to all PIPs, we decided that the rule should be that view controller is implemented one by one to each PIP. By using target view controller, PIP can now be displayed anywhere. Next is about audio session. We added the middle management layer, and it is using weak reference dictionary to manage the state. In order to fix the faults, we added some options such as setting other than the session setting of the state. This is how we realized PIP. In line, we do not hesitate to make such structural change that would impact line overall. We are never conservative. And this is a major project that is cross-border in its nature. And we are actively conducting such changes in order to make a better application. Please enjoy PIP to view videos and while talking. That is the end of my presentation. Thank you very much.